Question number 11. For determination of molar mass of polymers and proteins, which colligative property is used? Relative lowering of vapor pressure, elevation of boiling point, osmotic pressure, depression in freezing point. Here the answer is osmotic pressure. So osmotic pressure method is used to determine the molar mass of polymers and proteins. So 11th question, option C is the answer. 12th question is a 5% by mass solution of glucose, molar mass is 180 gram per mole, is isotonic with 1% solution by mass of the substance X. The molar mass of X is. Here also we can use osmotic pressure, equation for osmotic pressure, that is, it is about isotonic solution. So solutions are isotonic in nature, so we can write pi 1 is equal to pi 2. So in this case C1 RT equals C2 RT. So RT and RT get cancelled. So we can write WB by MB equals WB by MB. So this is for the first set, this is for the second set. So in the first case WB equals 5, so mass equals 5 and molar mass equals 180. So 5 by 180, which is equal to, then 1%, that means WB equals 1 divided by molar mass of the second solution, that is MB itself. So this is the case. So we can find out MB, which is equal to 180 divided by 5, which is equal to 36. So 36 gram per mole, that is the answer. So option A is the answer. Option A. Option A is the answer for 12th question. Now let's see 13, question number 13. So the freezing point of 0.2 molar solution of non-electrolyte in water is, Kf is given, that is 1.86 kg per mole. So in this case we can write delta TF. Delta TF is equal to Kf into M. So that is molality. So it's a non-electrolyte. It's a non-electrolyte. So the I value. So the I value is 1. So we can write Kf into M only. So I will be 1 here. So delta TF equals 1 into Kf, which is given 1.86 into, then molality is 0.2 molar solution. So delta TF is equal to 0.372, that is delta TF. So the question is the freezing point. We need to find out the freezing point. Freezing point is TF. So TF is equal to, the answer is given in degrees Celsius. So we need to find out the answer in degrees Celsius itself. So TF is equal to T0F minus delta TF. So T0F is freezing point of the pure solution, that is equal, pure solvent, that is equal to 0 degrees Celsius. So minus delta TF is 0.372. So the answer is minus 0.372 degrees Celsius. So option A is the answer. Option A is the answer. Then question number 14. When 2.5 gram of a non-volatile solute was dissolved in 50 ml of water, it give boiling point elevation is 0.52 degrees Celsius. The molar mass of the solute is Kb for water is given. So in this case, question number 14, that is delta TB, that is about boiling point elevation. So we can use this equation, delta TB is equal to Kb into M. So we can write Kb into molality. Instead of molality, we can write Wb by Mb into 1000 divided by Wa. So which is equal to 0.52. Kb is given. Wb equals 2.5 grams. So 2.5 divided by Mb we need to find out. Then 1000 divided by Wa is 50 ml. So it is 50. And delta TB, that is also given. The boiling point elevation is 0.52. So 0.52 itself. So we need to find out Mb. So Mb equals 0.52 divided by 0.52 into 2.5 into 20. So which is equal to 50 gram per mole. So the answer is option B. Option B is the answer. Then question number 15. Which of the following aqueous solution should have the highest boiling point? Which of the following has the highest boiling point? So the options are 1 mole NaOH, Na2SO4, NH4NO3 and KNO3. So in these options the concentration is the same, but the solutes are different. So we need to find out which is having highest boiling point. So question number 15. In this case, we need to find out the I factor, that is boiling point. If delta TF is higher, delta TB is higher, TB also will be higher. That is, if elevation in boiling point is higher, boiling point of the solution is also higher. So this delta TB is equal to, or which is equal to I into Kb into M. So if this solution has the same concentration, delta TB is directly proportional to I factor. So boiling point elevation is directly proportional to I factor. So we are having the electrolytes like NaOH, Na2SO4, NH4NO3 and KNO3. So we need to find out the number of particles dissociated in each case. That means that gives the I value. So in this case, NaOH on dissociation gives Na plus plus OH minus. So the I factor is equal to 2. Then in the case of Na2SO4, it is 2Na plus plus SO4 2 minus. So I factor is equal to, it will be 3. So 3 particles or 3 ions are formed here. So I factor is equal to 3. In the case of NH4NO3, it is NH4 plus plus NO3 minus. So I factor is equal to 2. In the case of KNO3, it is K plus plus NO3 minus, so I factor equals 2. So 2 ions are formed. So in this case, I factor is 3 for Na2SO4. So number of particles dissociated is more in the case of Na2SO4. That means I value is more in this case. So if I value is more, that will directly affect the elevation in boiling point. Consequently, the boiling point of the solution will be higher. So delta TB is higher, TB will be automatically higher. So the colligative property, actually this colligative property depends on the number of particles. So the number of particles dissociated in each case is written. So the number of particles dissociated, that is the I value is 3 in the case of Na2SO4. So this aqueous solution is having the highest boiling point. So the answer is option B. Option B is the answer here.